The Great Pyramid of Giza is 4,500 years old. Consists of 2.3 million stone blocks, each weighing between 2 and 70 tons. The blocks are fitted together with such precision that you cannot slide a piece of paper between them. The structure is aligned to true north with an accuracy of 3/60th of a single degree. It remained the tallest human-made structure on Earth for 3,800 years. Modern engineers, with computer-aided design, GPS surveying, steel cranes, and diesel-powered machinery, would struggle to replicate the Great Pyramid's precision and scale. Yet the ancient Egyptians built it with copper tools, wooden sledges, and rope. This is the paradox that has haunted archaeologists, engineers, and historians for centuries. How did a Bronze Age civilization without iron tools, without the wheel for construction, without pulleys or advanced mathematics as we understand them, build something that remains an engineering marvel even by 21st century standards? The conventional explanation is simple. Massive labor forces, simple tools, and lots of time. But when you examine the actual engineering challenges involved, this explanation becomes increasingly inadequate. The precision required, the logistical complexity, the sheer physical impossibility of some aspects of the construction. Something is missing from our understanding. Some technique, some technology, some knowledge that the ancient Egyptians possessed and that we have lost. This isn't about aliens or pseudoscience. This is about engineering. Real physical engineering that accomplished things we can observe but cannot fully explain. And the more closely modern engineers examine the pyramids, the more they realize that the ancient Egyptians knew something we don't. The precision problem. Start with the most basic question. How do you cut 2.3 million stone blocks with such precision that they fit together with gaps of less than 1/50th of an inch? The conventional answer is copper tools. The Egyptians had copper chisels and saws. Copper is soft, but combined with sand is an abrasive. It can cut through limestone and even granite. But here's the problem. Experiments conducted by modern researchers using copper tools and sand have shown that cutting a single limestone block to the required precision would take approximately 400 man-hours. For 2.3 million blocks, that's 920 million man-hours of cutting alone. The Great Pyramid was built in approximately 20 years. If we assume continuous work 24 hours a day, 365 days a year, that's 175,000 hours. To accomplish 920 million man-hours of cutting in 175,000 hours would require over 5,000 workers doing nothing but cutting stone. Continuously for 20 years, that's just cutting. It doesn't include quarrying, transporting, lifting, or placing the blocks. When you add those tasks, the workforce required becomes astronomical. Estimates range from 20,000 to 100,000 workers. The Egyptians probably did have large labor forces, but the precision problem remains. How do you maintain tolerances of less than 1/50th of an inch across 2.3 million blocks using hand tools? Modern stonemasons, using steel tools and measuring instruments, struggle to achieve such precision consistently. The ancient Egyptians apparently did it routinely. The lifting problem. The second fundamental problem is lifting. Some blocks in the Great Pyramid weigh 70 tons. They're positioned over 200 feet above ground level. How do you lift a 70-ton block to that height without modern machinery? The conventional explanation is ramps. The Egyptians built massive earthen ramps that spiraled around the pyramid, or approached it from one side. Workers would drag blocks up these ramps using wooden sledges and rope. But this explanation has serious problems. To reach the height of the Great Pyramid, 481 feet, a ramp with a reasonable gradient, perhaps 110, would need to be over 4,800 feet long. The volume of material required for such a ramp would exceed the volume of the pyramid itself. Moreover, as the pyramid got taller, the ramp would need to be constantly extended and raised, requiring continuous reconstruction. The logistics of building and maintaining such a ramp, while simultaneously building the pyramid, seem nearly impossible. Some archaeologists propose internal ramps built within the pyramid structure itself. But no clear evidence of such ramps has been found, and the internal space required would compromise the pyramid's structural integrity. Alternative theories include lever systems, counterweight systems, and various mechanical advantage techniques. But none of these fully explains how blocks weighing 70 tons could be lifted to heights of 200+ feet with the technology available to Bronze Age Egyptians. The alignment problem. The Great Pyramid is aligned to true north with an accuracy of 3/60th of a degree, approximately 0.05 degrees. This is extraordinary precision. Modern surveying with GPS can achieve similar accuracy, but doing so 4,500 years ago requires explanation. The conventional answer is astronomical observation. The Egyptians could observe circumpolar stars, stars that never set below the horizon, and use their positions to determine true north. This is theoretically possible, but achieving 0.05-degree accuracy through naked eye observation is extremely difficult. Moreover, the pyramid's alignment isn't just close to true north. It's aligned with a precision that suggests deliberate engineering rather than approximate astronomy. The builders knew exactly where true north was and had methods for ensuring the structure remained aligned throughout construction. This implies surveying techniques that were far more sophisticated than the simple tools we believe the Egyptians possessed. String lines and plumb bobs can establish level surfaces and right angles, but maintaining alignment across a structure covering 13 acres requires something more. In recent decades, some engineers have proposed a radical alternative explanation for how the pyramids were built: water. The theory, developed by French architect Jean-Pierre Houdin and supported by engineers who have examined the internal structure of the Great Pyramid, suggests that the Egyptians used water-based construction techniques that have been completely lost to history. The core idea is surprisingly simple. Water can be used as a leveling tool with near-perfect precision. A water surface at rest is perfectly level. If you create a series of water-filled channels around a construction site, you can ensure that all measurements are taken from a perfectly level reference plane. But the theory goes further. Houdin proposes that the Egyptians may have used water locks, essentially primitive elevators, to lift stones. By creating sealed chambers that could be filled and drained, heavy stones could be floated on rafts and raised without the need for ramps. The physics is sound. A 70-ton stone would displace approximately 70 cubic meters of water. A chamber 10 meters square and 7 meters deep filled with water could float such a stone. By carefully controlling water levels, the stone could be raised to any required height. Evidence for this theory comes from several sources. Internal shafts. The Great Pyramid contains internal shafts of unknown purpose. Some researchers believe these may have been water channels or air vents for water-based construction systems. Erosion patterns. Some limestone blocks show erosion patterns that suggest prolonged water contact. This would be consistent with blocks being stored or transported in water-filled chambers. Harbor facilities. The pyramids at Giza were built near the Nile, and evidence suggests extensive harbor facilities that could have been used for water-based transport and construction. Mathematical sophistication. Using water for precision measurements requires understanding of hydraulics that suggests mathematical sophistication beyond what we typically attribute to ancient Egyptians. The water theory is controversial. Many archaeologists dismiss it because no direct evidence of water locks or hydraulic systems has been found. But absence of evidence is not evidence of absence. If the Egyptians used temporary wooden structures filled with water, those structures would have left minimal archaeological traces after 4,500 years. The acoustic theory. Another intriguing proposal comes from acoustic engineers who have studied the interior chambers of the Great Pyramid. They've discovered that the king's chamber has unusual acoustic properties. Sounds at certain frequencies resonate powerfully within the chamber, while sounds at other frequencies are absorbed or cancelled. Some researchers believe these acoustic properties were intentional, that the Egyptians understood acoustics to a degree we don't give them credit for, and that acoustic resonance might have been used as a construction tool. The theory is speculative, but based on real physics. Sound waves at specific frequencies can cause solid objects to vibrate. If you can generate powerful acoustic resonance, you might be able to reduce friction between stone surfaces, making massive blocks easier to move. Modern technology uses similar principles. Ultrasonic vibration is used in various industrial applications to reduce friction, and facilitate movement of heavy objects. Could ancient Egyptians have discovered similar techniques using resonant chambers and carefully tuned sound generation? The evidence is circumstantial. The acoustic properties of the pyramid chambers are real and measurable. Whether they were intentional and whether they were used for construction remains speculative. But the precision of the acoustic design suggests it was no accident. The geopolymer theory French material scientist Joseph Davidovits has proposed perhaps the most controversial theory, that the pyramid blocks weren't quarried and moved at all. They were cast in place using ancient concrete. Davidovits argues that the ancient Egyptians developed a form of geopolymer, concrete, essentially artificial stone created by mixing limestone aggregate with a binding agent. This concrete could be poured into molds at the construction site, eliminating the need to transport massive blocks. The theory is supported by several observations. Microscopic analysis. Some pyramid blocks show microscopic characteristics more consistent with cast material than with natural limestone. Organic inclusions. Some blocks contain organic materials, hair, fibers that wouldn't naturally occur in quarried limestone but would be consistent with concrete that was mixed and poured. Weight distribution. The blocks are sometimes lighter than equivalent volumes of solid limestone, suggesting they might be composite materials rather than solid. Stone precision. Casting blocks in molds would more easily explain the extraordinary precision of the fit between blocks. The mainstream archaeological community has largely rejected this theory. Most geologists who have examined pyramid blocks believe they are natural limestone. But Davidovits's work has opened a legitimate scientific question. Could the ancient Egyptians have developed forms of concrete or synthetic stone that we don't recognize as artificial because they're too similar to natural stone? Setting aside speculative theories, let's focus on what we can prove the ancient Egyptians knew. Advanced mathematics. The pyramids demonstrate understanding of pi, Fubai, the golden ratio, and complex geometric relationships. The ratios embedded in the Great Pyramid's dimensions encode mathematical constants that wouldn't be officially discovered for thousands of years. Sophisticated astronomy. The pyramid alignments demonstrate precise astronomical knowledge. The Egyptians understood celestial mechanics well enough to orient structures to cardinal directions and potentially to stellar positions. Materials. Science. The Egyptians knew how to work with copper, bronze, wood, and stone to create tools capable of cutting and shaping hard stone with precision. They understood properties of different stones and how to exploit those properties. Logistics. Building the Great Pyramid required feeding, housing, and organizing tens of thousands of workers for 20 years. This implies sophisticated organizational systems, accounting methods, and resource management. Hydraulics. The Egyptians built sophisticated irrigation systems for agriculture. They understood how water behaves and how to control its flow. Whether they applied this knowledge to construction is unknown, but they had the foundational knowledge. The lost knowledge problem, the most troubling aspect of pyramid construction, isn't any single technique, it's the fact that the knowledge was lost. The pyramids were built primarily during the Old Kingdom. 686-2101 BCE. Pyramid construction peaked with the Great Pyramid around 2560 BCE. After that, pyramid construction continued, but quality declined. Later pyramids were smaller, less precisely constructed, and structurally inferior. By the New Kingdom, 1550-1077 BCE, Egyptians had stopped building pyramids entirely. The knowledge of how to build them appeared to have been lost or abandoned. This is unusual in technological history. Typically, knowledge accumulates and improves over time. Techniques get better, not worse. Yet pyramid construction seems to have regressed. Why? One possibility is that pyramid construction required specialized knowledge held by small groups of master builders. When those builders died without passing on their knowledge, techniques were lost. Another possibility is that the Great Pyramids were built using techniques that were economically or logistically unsustainable. Perhaps the methods worked, but required resources that later periods couldn't or wouldn't commit. A third possibility is that the knowledge wasn't lost. it was deliberately restricted. Some researchers believe pyramid construction involved secret techniques known only to priestly classes, and these techniques were never written down. Modern replication. Several modern researchers have attempted to replicate ancient Egyptian construction techniques to test whether conventional explanations are adequate. The Nova Pyramid. In 1997, Nova Television produced a documentary where a team attempted to build a small pyramid using ancient Egyptian techniques. They succeeded in building a structure about 20 feet high using copper tools, wooden sledges, and ramps. However, the experiment revealed significant problems. The copper tools wore out extremely quickly. The ramps were difficult to build and maintain. The precision achieved was far below that of actual ancient pyramids. The experimenters concluded that while the basic techniques could work in principle, achieving the scale and precision of the actual pyramids would require refinements and efficiencies they hadn't discovered. The Obelisk Project. Researcher Mark Lehner led a project attempting to move a 35-ton obelisk using ancient Egyptian methods. The team succeeded in moving the obelisk short distances, but found it enormously difficult. Extrapolating to the hundreds of 70-ton blocks in the Great Pyramid suggested that conventional techniques would require modifications or efficiencies not yet understood. Stone cutting experiments. Various researchers have attempted to cut limestone using copper tools and sand abrasives. The consensus is that it's possible but extremely time-consuming. Achieving the precision of actual pyramid blocks consistently would require techniques beyond simple cutting. These replication attempts don't prove that conventional explanations are wrong, but they do demonstrate that our understanding of ancient techniques is incomplete. Something is missing from the picture: the evidence in stone. Perhaps the most compelling evidence that the ancient Egyptians possessed sophisticated technology is the pyramids themselves. They exist. They demonstrate capabilities that we struggle to fully explain. The evidence isn't speculative, it's physical. Consider the interior chambers of the Great Pyramid. The King's Chamber contains granite blocks weighing up to 80 tons, positioned with millimeter precision over 200 feet above ground level. The blocks are fitted so precisely that the joints are barely visible. The chamber ceiling consists of 9 granite slabs, each weighing approximately 50 tons, placed without mortar. These slabs have supported the weight of the pyramid above them for 4,500 years, without cracking or shifting. Modern engineers, asked to design such a structure, would use steel reinforcement, precise computer-aided measurements, and carefully controlled construction processes. The ancient Egyptians achieved comparable results with technology we believe was far more primitive. Either our understanding of that technology is incomplete, or the Egyptians possessed capabilities we haven't recognized. It's important to address alternative explanations that have been proposed, ranging from plausible to pseudoscientific alien technology. Some popular theories claim the pyramids were built with extraterrestrial help. This is unsupported by any evidence and unnecessary. Human beings are perfectly capable of sophisticated engineering. We don't need to invoke aliens to explain human achievement. Lost civilization. Some theories propose that pyramid technology came from a lost advanced civilization, Atlantis, etc., that predated ancient Egypt. Again, there's no evidence for this. The pyramids fit within the archaeological record of Egyptian civilization. They represent the pinnacle of Egyptian achievement, not imported technology from elsewhere. Giant workforce with simple tools, the conventional archaeological explanation. Large numbers of workers using basic tools, ramps, and rope. This explanation is plausible, but struggles to account for the precision and efficiency demonstrated. Sophisticated lost techniques. The hypothesis that Egyptians developed specific engineering techniques that were later lost. These techniques would have been within the technological capabilities of the time, but more sophisticated than we currently recognize. This is perhaps the most scientifically defensible explanation: the knowledge gap. The fundamental mystery isn't whether ancient Egyptians could have built the pyramids with available Bronze Age technology. Clearly they did. The pyramids exist. The mystery is how they did it so efficiently and precisely. What specific techniques, tools, and methods allowed them to achieve what we struggle to fully explain? This isn't a gap that pseudoscience needs to fill with aliens or magic. It's a legitimate engineering question, and it has a rational answer. We just don't know what that answer is yet. Modern implications, understanding how the pyramids were built, isn't just historical curiosity. It has practical implications for modern engineering. If the ancient Egyptians did develop sophisticated water-based lifting systems, those principles might be applicable to modern construction in developing regions where heavy machinery isn't available. If they used acoustic techniques to reduce friction, similar methods might be useful in modern materials handling. If they developed forms of concrete or synthetic stone, understanding those materials could inform modern construction materials science. The pyramids represent a data point in human engineering capability. Studying them isn't about glorifying the past. It's about understanding what's possible with human ingenuity, working within constraints. The Great Pyramid has stood for 4,500 years. It has survived earthquakes, climate changes, and millennia of human history. It will likely stand for thousands more years. Modern skyscrapers built with steel and concrete and sophisticated engineering will not last 4,500 years. They'll corrode, collapse, or be demolished long before reaching the pyramid's age. In that sense, ancient Egyptian construction technology was more durable than our own. This is humbling. We have computers, steel, diesel engines, and advanced mathematics. Yet we cannot build something as enduring as what Bronze Age Egyptians built with copper tools and human labor. What does this tell us? It tells us that technology isn't always linear, that ancient peoples were capable of achievements we underestimate, that sophistication can manifest in ways we don't immediately recognize. The pyramids stand as monuments not to aliens or lost civilizations, but to human ingenuity, to the capability of human beings to solve impossible problems through observation, experimentation, and persistence. The ancient Egyptians didn't have our technology, but they had something equally valuable: intimate understanding of materials, physics, and engineering principles derived from direct observation of the physical world. They couldn't calculate stress loads using computer models, but they understood how stone behaves under compression through empirical observation. They couldn't use GPS for alignment, but they understood celestial mechanics through careful astronomical observation. In many ways, their engineering was more elegant than ours. It worked with nature rather than against it. It used simple principles applied with precision, rather than complex systems requiring maintenance. The lost technology of the pyramids isn't magical. It's practical, physical engineering that exploited principles of physics we understand, but applied them in ways we've forgotten or never learned. Someday, we may fully understand how the pyramids were built. We may discover documentary evidence, archaeological remains of construction equipment, or develop techniques that allow us to perfectly replicate ancient methods. Until then, the pyramids remain what they've always been: a challenge to human understanding, a reminder that our ancestors were as intelligent as we are, as capable of solving complex problems, as sophisticated in their thinking. They simply did it differently. And in some ways, they did it better. The pyramids stand as proof that with sufficient intelligence, determination, and understanding of fundamental principles, human beings can accomplish engineering feats that seem impossible. We don't need aliens or lost civilizations to explain human achievement. We just need to remember that intelligence and ingenuity are constants throughout human history. The tools change, the materials change, the methods change, but the human capacity to observe, to think, to solve problems, and to build the impossible, that remains constant. The ancient Egyptians proved it 4,500 years ago, and their proof stands in the desert, defying time, weathering millennia, challenging us to understand. We look at the pyramids and ask, how? Perhaps the better question is, why have we forgotten? Because somewhere in the gap between their capabilities and our understanding lies knowledge that was lost. Not supernatural knowledge, not alien technology, just human engineering at its most sophisticated, achieved with tools we consider primitive. The pyramids are technology, ancient, lost, and still not fully understood. But technology nonetheless, and that's what makes them truly remarkable.